Let's look at this example. Are the graphs of the following equations lines? To decide if the graph of an equation is a line, we see if the equation could be written in the standard form of a line, which is ax plus by equals c, where a, b, and c here are real numbers. The other condition is a and b cannot be 0 at the same time. In other words, either a cannot be equal to 0 or b cannot be equal to 0. They can't be 0 at the same time. Now let's look at a. Negative x equals 3x plus 10. We want to see if we can write this equation into the standard form of a line, which we could, right? We can move the 3y into the right side of the left side of the equation. So that will give you on the left side is negative x minus 3y. Notice we can't combine like terms here because they are not like terms. Equals, these two cancel out, equals 10. Okay, then you look at this equation in the standard form of a line. So that means this equation does represent a line. So the answer is yes. This is a line. Okay, now let's look at b. X equals y. Right, so can we write this equation in the standard form? Well, we could try, right? Let's move the y to the left side by subtracting y on both sides. Okay, here we'll give you x minus y equals 0. Okay, so this is in the standard form of a line, right? What is a? A is 1, right? It's 1 times x. And what is b? B is negative 1, right? Because it's negative 1 times y. So b is negative 1, where c is 0. So it does satisfy the standard form of a line. That means, yes, this equation is also a line. Now let's look at c. X squared plus 2y equals 0. It seems like we cannot write this equation in the standard form of a line because you have x squared here in the way. So there's no way you can write it as ax plus by equals c, right? Because you're having x squared here. The degree of the x is not 1, it's 2. So the answer here is no, this equation doesn't represent a line. Now let's look at d. Y equals negative 1. Does this equation represent a line? Well, we have to look at the definition, right? Does this satisfy the standard form of a line? Well, it looks like we're missing the x term, right? We have a y term here, we have a c here, but we're missing the x term. But wait a minute, we can call it a equals to 0, right? So if a equals to 0, the x term is gone. So in this case, your a is equal to 0, your b is equal to 1, c is negative 1. Well, does it represent a line? Well, here a and b are not 0 at the same time, right? Only a is 0, b is not 0. So yes, the graph of this equation is still a line. Similar for e. X equals 25. We're missing the y term here, but we can consider y, the coefficient of the y is equal to 0, which means b is equal to 0, where a is the number in front of x, which is 1. So we can kind of see this equation as 1 times x plus 0 times y equals 25. That means we have an x term and we don't have a y term, and c is 25. it still satisfies the standard form of a line because A and B are not 0 at the same time, right? Only one of them. Only A is one. Only B is 0. A is not 0. So yes, the equation of x equals 25 is still a line. Now let's check for understanding. Here we have 5 equations. Please decide if they represent lines or not. You can pause this video and check for understanding, check for the answer when you're done. I'm going to review the answers in 3 seconds. 3, 2, 1. Here are the answers. Did you get them all right? Hopefully you did.